All right, here's 3, 4, day 2. We're going to kind of do the opposite here that we did in day 1. What I mean by that is, for the most part in day 1, we said, hey, here's a polynomial. Let's go find some zeros. Okay, this is kind of the opposite, where it's like, hey, here's some zeros. What polynomial or what possible polynomial would have those zeros? Okay, which I like about this is we're really getting into the connection between zeros and factors. Okay, we'll start with a pretty easy one, right, with a quadratic. Okay, it says a is 1. You'll see that come up a little bit. So it's one thing to like write the equation off of the zeros to get the factors. That doesn't necessarily tell you what a is, because you could still have the same zeros and the function could be like really tall and skinny or wider, but again, the zeros can be in the same spot. So kind of stay tuned to a. Sometimes it tells us what it is. If it doesn't and we need to make it up, sometimes we'll just say that a is 1. So be ready for that. But here's what we're looking at for our function, f of x. A is 1, so that really doesn't need to be there, but whatever. If it had a 0 at 4, it's got a factor at x minus 4. And if it's got a 0 at 5, it's got a factor at x plus 5. Again, that value of a being 1 out here isn't really doing anything, so just leave that alone. Now we'll do some foiling. X squared plus 5x minus 4x minus 20. As we typically do when we FOIL a quadratic, you've got two like terms in the middle. And there you have it. You have a quadratic function. Its value of a is 1, and it has two zeros, one of which is at 4, the other is at negative 5. All right, so a quadratic was a nice little one to start with, but let's get real. Let's up the stakes here in a couple of ways, okay? Number one, let's go to a cubic, all right, which we can handle. Let's do a cubic. Gives us 2. 4 and 2 plus I. Okay, but here's where you can't let it fool you. We talked yesterday. Didn't really see it in action. Well, we saw it a little bit in one of the first slides yesterday. Okay, so you've got 1 at 0, 2 plus I, and 2 minus I. Okay, imaginary zeros always come in pairs. So this would be a real possibility that we could have of a third degree polynomial that has one real zero at 4 and then 2 imaginaries. Okay. It doesn't say anything about a. Okay, and I'm not expecting you to find it. So the last problem, just set it flat out. We'll say it here. Let a be 1. Okay, let a be 1 and let's not worry about it, because typically speaking, you know, to get going here, I'd have a factor at x minus 4, but what I'm saying is this whole thing with a, don't even worry about it. Okay, just assume it's 1. I think on the last problem of the day, because we're looking at 4 of these total, the last one will actually get into, well, no, the last one will actually get into a. Okay, the last one will actually get into finding, because really if we wanted to get serious about it, we need a point that our polynomial goes through. Okay, we need a point that our polynomial goes through. All right, so here's where things could get a little bit tricky. Oops. I was going for an eraser. So you've got these two imaginary ones left. Here's how I would approach it, okay? You're going to have a quadratic. That's not good. Not good at all. My pen got fat. It became a marker, which I kind of like it. It just wouldn't work very well. Wouldn't work very well writing with it. Okay, so it's going to be a quadratic. Okay, but here's the thing. It's got a coefficient of 1, and I've got the two zeros. So here's what you're going to have. Actually, let me back up one step. Let's do the same thing to get it started. Okay, so if there's a 0 at 2 plus I, there would be a factor at x minus 2 plus I, and another one at x minus 2 minus I. So there you are. There's your three factors. Okay, I should have started there right away. So these two over here, if we were to FOIL those, it's going to be a quadratic. Okay, and the coefficient in front of that quadratic is 1. So let's take this approach. We've seen with quadratics that if you have the two zeros, it's x squared minus the sum of those two factors, plus it would finish with the product. This is kind of a weird one. We want to get to a cubic that has all real number coefficients. Okay, it actually says in there that we need to get real coefficients, but we're dealing with this issue that two of its zeros are imaginary. Okay, this is where we're going to make that jump. Okay, we got to figure out, what is 2 plus I plus 2 minus I. Okay, so that's a really big thing right there, that for these two imaginary zeros, their sum is 4. Okay, that's going to be really helpful. Last, for the number at the end, I need their product. This is going to be 4 plus 2i minus 2i minus I squared. Those will cancel, okay? I squared is -1, right? But there's already a negative sign in front of it, so it's like a +1. So their product would be 5. So now here's what I can do, and this is really sweet. X minus 4, there was no problems with that. That's just a good old factor, okay? With a real number. All right, to get this basically like foiled to a quadratic, I can make the jump and say x squared minus 4x plus 5. Okay, that quadratic, from the way that's the work that we did up top. That quadratic has zeros at 2 plus I and 2 minus I. Okay, but I've made the jump back to those real coefficients, because again, if it has those two zeros, the sum, or that number in front of x, needs to be 4. And the product, or the number that goes at the end, needs to be 5. Okay? Now, at this point, let's just do a little distributing. I'm going to distribute the x first. We would get x to the third minus 4x squared plus 5x. Now distribute the -4. And we'll wrap it up here. Looking for any like terms. X to the third, doesn't have any. Got a couple x's squared. Those will combine. 5 and a 16, that can combine to 21x, and a minus 20 at the end. Okay, there's a cubic polynomial. It's got zeros at 4, 2 minus I, and 2 plus I. Fourth degree. Okay. Now we're going to do it again here, just right off the bat. I'm not going to play any games here. Coefficient out front, let it be 1. On our last example here, we'll get serious about what to do. All right, so we got 4 zeros. negative I, positive I, 3I, and they keep trying to trick us by not giving the last one, but we know better, okay? Minus 3I. They got to come in pairs. Okay. All right, if it has a 0 at 1, we have a factor at x minus 1. If we have a 0 at negative 1, there's a factor at x plus 1. Okay, so far so good. Okay, there's all four, okay? Now, check out what I'm going to do here. It's actually going to work out really slick. I could, if I wanted to, do the same thing with this part, right? Because this is where we've got the factors that are coming from imaginary zeros, right? This one is fourth degree, so it's 2 and 2. 2 real, 2 imaginary. It's not that a fourth degree has to have 2 imaginary, but if it does, this is one way it could break down. 2 real, 2 imaginary. If you wanted to just FOIL this, you absolutely could, right? Here, it's a much easier scenario than what we had before. If you still want to just look at the imaginary numbers and take their sum and product, this is going to work too, right? You add them together and you get 0. Their product would be negative 9i squared, which put in negative 1 for I squared, you would get positive 9, okay? So you could have x minus 1, x plus 1, okay? To get to that jump to real coefficients, with these imaginary ones, you could do x squared plus 9. That'll work, okay? Now, if you had just kind of taken this and done like the traditional foiling methods, right? Because it's not the imaginary terms aren't like the sum of the two parts. Like the other one with 2 plus I and 2 minus I, that would not have worked well to FOIL. It can be done. The algebra is going to be kind of nasty. Okay? It's going to be kind of nasty. This one would work fine. But if you like this whole idea of just finding the sum and the product of the two imaginary numbers, go with it. It'll work. Okay? Now, the only other thing is I actually need to do some foiling with the first two that are coming from the real zeros. My x squared plus 9 is still out there. A couple like terms in the middle. I end up with this, x squared minus 1 times x squared plus 9. A little goofy here, but we can treat it like a FOIL. X to the 4th plus 9x squared minus x squared minus 9. Two like terms in the middle and a constant at the end, and there you have it. Okay, fourth degree polynomial. One thing I know about that polynomial, which again, we simplified the process, right? Because it's really right here. I'm saying for all these that a is 1. Technically speaking, that is kind of a different deal that we're going to look at in the next one as to if that number was something other than 1, what would we have to do to figure that out? So whatever, we're saying a is 1. But we have a fourth degree polynomial, and something that I know about that polynomial from the way I built it, it has a 0 at negative 1, it has a 0 at positive 1, it's got a 0 at 3i, and a 0 at negative 3i. Okay, it was I built it so that it had those 4 zeros. All right, down here, okay, we're back to third degree. Right? We dabbled there for a little bit at fourth. Good for us. That tends to be so far. I mean, I don't think we've really seen much with fifth degree. So fourth is kind of as high as we've gone. We're back to third. But this one's got a new little wrinkle to it. We're going to find a. Okay, but notice game changer. We're able to do that. Look at right here. It tells us for this polynomial function, this third degree polynomial, that when x is 1, y is 3. Okay? When x is 1, y is 3. All right, good enough. Let's get started. Okay, so what I'm going to do here now is instead of just saying that a is 1, obviously not going to do that. But I am going to put in a, and this, as we kind of do the steps, this might get a little bit annoying. A is just going to sit in there, right? Because I got to get to it by the end to figure out, exactly what it is. This has to have a factor of x minus 2. It's got a factor of 1 minus x minus 1 minus I. And of course, don't forget, that means we have another imaginary 1 at. Okay, so I'm going to do the same thing right here. This needs to get to convert it over to a quadratic that has real coefficients. So we go back to the same question, right? The sum and the product. Adds up to 2. One plus I minus I. Remember, I squared is -1, so when you plug that in, it's really like 1 plus 1. So there you go. So let's kind of bump everything down to here. Still need a. I've got x minus 2, okay? But these two imaginary zeros are coming from a quadratic that would be x squared minus 2x plus 2, okay? And from here, we're good to do a little distributing. Again, a will sit out front, but let's distribute the x and get x to the third minus 2x squared plus 2x, okay? Now let's do the -2. We will get minus 2x squared plus 4x minus 4. As always, looking for like terms. Looks like I've got nothing to go with x to the third. Minus 4x squared plus 6x minus 4. Okay? Now, if we were doing it like we had done the other problems, we'd say we're done, right? We've got it because out front with that value for a, we'd be saying a is 1. Just let a be 1 and we'll call it good. Okay? Well, we can't do that here because it says when x is 1, y is 3. Okay, so here's what happens now. I go here. My y value is 3. I'm looking for a. Everywhere I see an x, I have to put a 1. You take a look at that and you're like, well, I mean, okay, you can get a. All right, because this would be 1 minus 4 plus 6 minus 4. Which, if you check all that, I believe it's -1. Divide both sides by -1, and you get that a is -3. okay? Now, last thing. This one is turning into a bit of a monster here. Not in a bad way, but it's got a little bit of extra steps here to get that it's -3. But if I go back up to basically here, and this is not a big last step at all. Right, I've got -3 out front, but then I've got x to the third minus 4x squared plus 6x minus 4. I would say to get a final answer, just go ahead and distribute the -3. So you get -3x to the third plus 12x squared minus 18x plus 12. And there it is. And again, keep in mind, okay, basically everything from here on down was kind of in addition to the other problems that we had done, right? Because again, it told me when x is 1, y is 3, right? So I'm like, okay, I got a little bit more. I got to plug in 1 and 3, right? And I got to work to get that, a, the leading coefficient, that it's actually -3. That's the number I'm looking for. All right, that is all for 3.4. More to come on 3.5.